Okay, so now we have to drill and tap this hole here. So this is a quartering hour drawing, is the 1032 2B. It goes through one wall. We already did the countersink for it. So provided that was modeled the right size and the tools are set right, that should be plenty. But we want to make sure we don't go too deep with this and gouge the other side of the bore here. Okay, so we're going to go to this menu here and we're going to go do a drilling. And we're going to select our tap drill. Okay, so we're going to go to our library and it's the 177.2 because we're using a form tap. If you're using a cutting tap, you'd have to have a different size. So tool 11. We're going to select that tool. We're going to keep everything at default feeds and speeds. Geometry wise, we're going to select the chamfer of the top of the part and the hole. That way we get the height of the top of the hole in the correct place. Now we want to drill as deep as we can because this hole isn't established yet. We want to make sure our tap doesn't hit bottom and break. So we're going to leave that as it is, but we're going to need to do a little math to figure out how deep we're going to go. Okay, we're going to go to heights, and again we're going to go from model top, and we're going to start at hole top, okay, which is the surface area where you see the blue cylinder. It'll include the countersink area. And then we're going to, we don't want to go to hole bottom. We want to calculate what is the distance we want to go. So it looks like it's defaulting its depth to the tip to where it would make a, it breaks the plane of this, or the circle cuts through the other circle. If we pick this through tip through bottom, then it'll bring the shoulder down to that level. And then this hole is nominally 1/4 inch in diameter, so we want to go deeper. Typically you want your tap drill to go 3 to 4 thread pitches deeper than your tap. So if this is our setting and we're breaking through tip and we are doing a 1032 screw, that means if we divide 1 divided by 32, our thread pitch is 31 thousandths. If we multiply that times 5, that gives us 156. So that would be the minimum we'd want to drill this hole. So if we put in a breakthrough depth of an additional 0.156, we still should not gouge into the opposite side. Okay, so let's do 1.8, and that brings us to where it shouldn't be gouging into the sidewall of our circle, but gives us plenty of room for our tap drill to go through and make a fully formed thread. Okay, we're going to cycle. We're going to do our deep drilling cycle, full retract. We'll leave the pecs alone. That 40 thousandths is fine. And then we go to our linking tab. There's really nothing to do there. Okay, so we want to remember how deep we went with this so that our tap doesn't go any deeper and bottom out. Okay, so we got some extra clearance. So we went a little more than 5 thread pitches deeper. Now we're going to go to drilling again, and this time we're going to select our tap. And it is the 1032 tap, tool number 14. Leave all this at default. Select our geometry. It's going to be the hole and the countersink. On our heights, again, we're going to start at model top. And then we're going to go to hole bottom. Now our tap has a flat tip to it, so I'm not sure how Fusion has it modeled. So we're not going to select this tip through bottom checkbox like we did with the drill. But we do want to do an offset And in this box, it has to be negative. If you check this box, another box appears and you put positive number there and it goes deeper. Okay, so let's do our calculation again. It's if we go an extra 4 thread pitches, or 5 thread pitches, that'd be 1 divided by 32. We're going to multiply that times 5. That gives us 156.25. We're not accounting for the drill point, so this should go shallower than what our drill did. So let's put a negative 0.156, and then we'll be assured that those first few teeth on the tap will create a thread all the way down to where we need to go. Alright, so if you want to double check, what we want to do is look through the side here. Okay, and then we're going to go to cycle, it's tapping, that's fine. Linking is fine, so hit OK. Alright, so let's compare our drill. So that's the depth of our drill in the side view, and then if we highlight over the tap, you can see that the drill bit is going deeper than the tap tip. So we should be good there. Alright, that concludes the first operation. Okay, now we're going to set up for the second operation. So I'm going to, for now, minimize the toolpath in operation 1. And I'm going to hide the vise for this operation and show the operation 2 vise. So we flip the vise around. If we did all our work properly in the beginning, we should be able to see the part in op2's configuration. And then we're going to turn the stock back on just for the first operation, and then after that the first routine, and after that we will be able to continue without the stock at all. The part itself becomes the stock. Okay, so now we're going to create a new setup. Okay, on this one we're going to use we're going to go to the stock tab, and we're going to use from previous. That's fine. On setup though, we're going to go instead of a model box, stock box point, z-axis and x-axis. We're going to set our z-axis plane as the top of the stock, and our x-axis is parallel to the long edge of the material. And then instead of a stock box point, we're going to use a model box point. And it looks like we've lost. This new setup isn't determining what the model is, so we're going to hit select on the model, and we need to pick the part itself. And now when we go to the box points, we should be able to select this bottom left corner, which is the top of the parallel, and that is our box point location. Okay, so the stock should be from previous. It really only has stock from the top corner down to where the part starts, but that's okay. There are some people that use simulation to bring in stock size from a previous operation. That's great. If you know how to do that, you can use the meshes. For a simple part like this, I don't bother with that. Okay, so our program number is 7312, and it's operation 2, so 73122. Program comment op2. We're going to stick with G54, so it's work offset 1. Hit OK. So our origin should show up there in the bottom. Op2. Okay, and we're going to use the similar tool we did on side 1. So let's expand side 1, and we can take our face mill and right click on that routine. And we're going to copy it, left click on op2, then right click on your mouse and hit paste. And we expand this, and now we have a copy of the face mill routine. Now we need to do some adjustment. Okay, and we're going to right click on the routine. We're going to hit edit. We're going to keep everything on feeds and speeds at default. On geometry, it'll select what is now faced up on the face mill, so we're going to accept that. We're going to go to heights, we do want to go from stock top, and the top height is going to be from stock top, and we want to machine down to model top. So it's going to machine between this light blue and this dark blue to deck down the top of this part. Okay, we're going to go to passes. We can leave all this at default. Worked on the other side, except for we want to hit multiple depths. This is too much for this cutter to take off in one pass. So we're going to check the multiple depths box. Our maximum step down is going to be 40 thousandths. We are going to go from both sides, and we're going to use even step downs. If you like, you can have a finishing step, and we would set that probably to 10 thou. I don't know if it really makes much difference with this cutter, but you might get a little bit better finish. And we go to our linking tab, and everything should be the same because we copied it from our previous routine. We hit OK, and we should get several passes. Goes back and forth and mills that down to height. Okay, at this point, the stock is effectively the model. So we can hide the stock, and we have a through hole here. And the only other routine we need to do on this side is our deburring. So let's go to our deburring op, which was this tool 15 with the chamfer, and on the first op, and we're going to right click on that, and we're going to copy it. I'm going to select back on op 2 and right click, and we're going to paste. Okay, that puts that chamfer routine in the operation 2 folder, and we need to select different geometry. So we're going to right click on the chamfer routine, we're going to edit it, we're going to leave the feeds and speeds alone. We're going to go to the geometry tab, and we're going to clear out the selections, and then we're going to select our new edges. Now in this case, actually, another way to do this would be to select the surface. Okay, so it gets both sides of it. We couldn't do that on the opposite side because it had an additional hole that it would have followed. Okay, on our heights, we're going to go from model top, we're going to selected contours, go to passes. We're still going to go to a chamfer width of 9 thousandths, just that's 1,000th under the tolerance. And a chamfer to tip, we leave all at the same. Go to linking, we should be able to leave all this at default, and let's hit OK. And we've now regenerated our toolpath on the opposite side. Right now, that because I don't have the face mill highlighted, it thinks there's still material around the outside edge because of the way I did the stock. So all that green material is not there on this routine. Okay, so that is done with op 2. Pretty easy. Now our third op, if we just go in suit, we are going to hide this instance of the vise, bring up the operation 3 vise setup, which should have the part as shown. Okay, we're going to have 3 operations in here. We're going to do the countersink with our chamfer mill, and then we're going to drill this hole with a 1/4-inch drill bit. Then we're going to need to add a special tool, which is the reamer, that's going to bring this to its finished size. Now if we look at our drawing, it's a 251 to 252 tool hole. We're going to use a 251 reamer to open that up. We're going to use that on a later project, so we're going to show you how to set that up. We're going to drill it. We're going to ream it to 251. Typically reamers run a little bit oversized when they're brand new, and if it spins out of true a little bit, it might cut a little bit big. So we're going to use a 251, and then we need to inspect this hole to make sure it hits our tolerance. So a 251 pin should slide in there smoothly, and a 253 should not. So if you haven't done that, you need to use gauge pins. Okay, so let's power on. We're going to do the first 2 routines with tools we already have. So let's go to setups, and we're going to do a new setup. Okay, and in this case, we are going to go to stock, and we're not going to use from previous because that material's all gone. We are going to go from solid though, and instead of selecting the stock, we're going to actually select our model. That is the stock. Okay, and it should give us the rough sizes of it. Now we're going to go back to setup, and we're going to select the body for the model is also the model. Our origin. Now, there's a bunch of ways you can do this. We could set it at the top, have it this top corner. We'd have it at the top of the parallel. It can be more accurate when you're doing multiple parts to base it off the fixture. I'm going to go ahead and be consistent that way. You might have other instructors that want you to set the origin at the top. But again, when you set up this on the machine, if you can cut this in the same day, you won't have to move your X and Y coordinates. You're just going to have to compensate for the fact this parallel is shorter than the others. And so the last two operations on this part are using the same parallel heights. The first two operations are using the same parallel heights. So you do need to change those out and make sure you have the right equipment in the machine when you run it. Okay, so we're going to do Z-axis and X-axis for our orientation. Pick on the top of the part, set Z in orientation to the part. We're going to select something that's horizontal and X to set our X-axis. And then in this case, stock or model box point is irrelevant because they're the same. And we're going to pick the model box point down in the bottom right left corner. This keeps our origin on the jaw. Okay, and then we go to post-process tab and we're going to put in our number. So this is part number 7312, operation 3. So our program number is 73123. Program comment op 3. And we're still going to use work coordinate system 1. Could change that if you wanted and use say 2 and you would output 56. But what's important is you set up the way your program is. I'm going to hit OK. We're going to change the name to op 3. And then we're going to do our first routine. So we're going to basically peck drill this the same way we did in operation 1. So if we go to the chamfer mill routine from op 1, it was tool 15, deep drilling. You can right click on that routine and hit copy. Then we go to op 3 and we hit paste. We'll need to expand op 3 and we can see the routine there. And right now it's trying to drill in from the side because that's what it did. So we're going to regenerate this. We go edit. Okay, we're going to keep everything on the first tab on default. We're going to clear the selection and we're going to select the countersink on the hole we're doing. We're going to go to heights. We're going to leave all this at default. Should do the right depth. It's a 3/8 diameter, so it should still be able to do this one. We go to the cycle, deep drilling, all stays the same. And then we go to our linking tab and leave that at default. Pretty easy, huh? All right, so now we've got a deeper countersink because this is a bigger hole. Now we're going to go to drilling and we're going to select our through hole, which is going to make a hole before our reamer goes in. So we're going to go to the aluminum library and we're going to pick our 1/4 inch carbide drill bit. Tool number 9. Select that. Keep the default feeds and speeds. Under geometry, we're going to select the chamfer and we're going to select the hole. Okay, we want to make sure you got both so it gets the right height. Then we're going to go to heights and we're going to model top and we're going to go to from the hole top to hole bottom. We want to break through the bottom tip, so we want to make sure it goes past. And this has got an angle to it, so we want to actually go a little bit farther. So we're going to go 0.1 deeper just to make sure we clear all of that and don't have a flash. Again, this is going to be important that we don't have our parallels on the center line of this thing. Okay, we're in a linking tab. We're going to do a deep drilling with full retract. We're going to leave the default pecs and we'll go to the linking tab, and there's nothing to set there. Okay, and so we should get our drill bit that goes through.